Sir, you have joined? Kamrul, sir?
Uh, Give me some moment, 2 minutes.
Yeah. You can make into presentation mode.
So the presentation slide can see, it is viewable.
Yes, yes, yes. It is visible.
How are you?
So what? Yeah, I'm fine. So what happened? Actually, this talk was by India time 2 p.m. But
Okay.
now it is preponed to India time 12 p.m.
Oh, so early.
Yeah. So because of your busy schedule,
Plus, yes, yes, yes.
yes. So we have done like that. Yeah.
Okay, okay. So I start now or need to
Yeah.
wait?
No formal way of introduction. Formal way we will start.
Okay, okay.
Asha, madam, you are there?
Yes, ma'am. I'm in the session.
Yeah. I think everybody join, na? Because
Yes,
Kamrul sir, actually everybody will think that they will join by 2 p.m. But now it is 12 p.m. So
Oh,
yeah, so more
okay.
than
So
100
it's
participants are.
can I wait? Can you wait 30 minutes more?
No, no, just we will start. People are
we
joining
have
65.
60 participants. Yeah.
Yeah, we can
Okay,
start.
right? Yeah,
We
okay,
have
okay.
written in the group. So Asha madam will read your biodata. Then you can start.
Yeah, yeah, okay, okay.
Okay.
Thank you.
Okay.
Okay, Asha
May I
madam,
start,
you
ma'am?
can.
Yeah.
Yes, yes.
Good afternoon, one and all. Ladies and gentlemen, it is with great honor and pleasure on behalf of the Oxford College of Engineering, I welcome you all to today's Faculty Development Program, second session, sixth day. Our distinguished guest speaker for the session needs no introduction in the realm of cutting edge technology and academia. Dr. Mohammad Kamrul Hasan, an associate professor and the head of the Network and Communication Technology Research Laboratory at the Cyber Security Center, Faculty of Information Science and Technology, University Kedangsaan, Malaysia, brings with him a wealth of expertise and experience that is truly remarkable. Dr. Kamrul's academic journey is nothing short of impressive. With a Doctor of Philosophy, and an MSc in Electrical and Communication Engineering from the Faculty of Engineering, International Islamic University, Malaysia, he has exemplified excellence in his field. His research spans across various domains, including information centric networks, wireless communication and networking, artificial intelligence, cyber physical system, smart vehicular networks, and smart grid and industrial IoT. Notably, Dr. Kamrul's contributions have been globally recognized as he has been selected as one of the top 2% scientists and highly cited authors worldwide by prestigious institutions such as Stanford University, elsewhere, and Web of Science. His extensive publication record, comprising over 330 indexed papers in ranked journals and conference proceedings, speaks volumes about his scholarly impact. Moreover, Dr. Kamrul is actively engaged in professional societies, holding senior memberships in the Institute of Electrical and Electronics Engineers IEEE, the Institution of Engineering and Technology, and the Internet Society. His dedication to advancing technology is further evidenced by his involvement in IEEE humanitarian programs in Malaysia and his role as an associate editor and guest editor for esteemed journals such as IEEE, Elsewhere, IET, MDPI, and Bentham Science. In essence, Dr. Mohammad Kamrul Hasan embodies the spirit of innovation, scholarship, and service to community. His presence here today is a testament to his commitment to knowledge dissemination and academic excellence. Please join me in extending a warm welcome to Dr. Kamrul as he shares his invaluable insights with us during this session. Thank you.
Thank you so much for your wonderful introduction for my bio.
Thank
So
you,
no
sir.
need to tell about me. Am I audible? And my
Yes, you're
slide.
audible, sir.
Okay,
Yes, sir.
great.
You
So
can
today
start now.
I'm going to talk about the smart grid computation, specifically the issues, challenges, and the latest solutions that we come across some real-time projects. And we saw some tutorials on the smart grid technologies that will help to sharpen the faculty their the understanding on the basic and the advanced level of smart grids. So I am Mohammad Kamrul Hasan. I'm working as associate professor and head of the lab in network and communication technology, and I'm in top 2% scientist in the Elsevier. So this is my research profile. You can find me in Google Scholar. You can find me in Web of Science, and you can find me in Scopus. My funded projects, like I have several funded projects. Here I highlighted only few. You can see that most of them are talk about the smart grid and the communication networks. And these projects are, the national and international collaboration based. Now we see about the what is the grid computation, so-called we see the smart grid. So when there is actually the generation to distribution to the home, there are some, the policy, some mechanism, some engineering, and some technology is there. So the electricity, when it develops or it generates from a media to another media, we transmit by using the digital and electric and the electronic, the helps in the form of the automation, communication, and IT system that can monitor power flows from point of generation to consumptions. So it may include a variety of the operational and energy measures, including the smart meters, smart appliance, IoT, artificial intelligence, information technology, automation, networking, and so on the other technologies. So this is, if you can see, this is the smart grid networks where we can see the generation can be a thermal plant, can be nuclear plant, can be solar plant, hydro, wind plant, and there are some transmission network, and in between the consumer and the generation, there is a control center where we can see, monitor, we can control, and we can maintain the network through this control center. Of course, there are some several digital equipments, for example, the SCADA. There are some phasor measurement system, programmable logic controllers, and some protocols will help to understand and bring the data from grid, from the consumer side to the operation center, so that we can observe the real-time occurrence in either in the grid generations or in the distribution side. So the data communication is very important, as I just told, that to measure, to monitor, and to maintain. There are some basic pipeline, or the foundation work, foundation infrastructure that can fetch the data from the grid to the observation and the usable subscription section, okay, through advanced metering infrastructure. So we can see that the real-time observation of data that can changes over the time, and we can observe in real time using the SCADA, using the local area network and the wide area network and the neighbor area network. So these actually the connectivity through the normal our the communication network by has some, but it has some specific the protocols, specific configurations, and specific the industry standard communication infrastructures that need to maintain. For example, home area network, it has a different the infrastructure and some sort of the standards maintained by the IEEE IEC. So we need to maintain this thing to the observe and to monitor the data the used by the different appliances activities, is energy storage, and also in the generation side. So this is whole process we call that the communication infrastructure or communication network, and we use the SCADA systems for the visualize the all the process generations, distributions, high voltage to low voltage, all the occurrences we can see in real time. We can monitor, control, and we can maintain the fault, the everything, the real-time activities. So this is actually, we can see in this graph, this is the advanced metering infrastructure, which also a part of the SCADA systems. So now we talk about the cyber physical systems. That is actually the where our the grid actually having some problem with the outsiders or insiders. So we need to understand that what kind of the outsider can, and where to the where they attack specifically in smart grid, and what devices need to monitor and care for the insider and outsider attackers. Okay, so if we see here that this diagram, we can see very clearly that we have the power delivery, the high for the high voltage, for the medium voltage, and the low voltage. You can see that in the low voltage we have these appliances, okay, and between these there are some the specific devices. Like if you see that there are some the merging units, there are some SCADA, there are some the communication links. So these actually the possible way that can the attacker can attack to understand the the cyber systems, and to some of the attackers, they can separate the networks. For example, this is a home network. Yeah, I take the pen so it will be easy. So maybe one attacker want to, I mean, discard one network from the system, so that what he can do, he can by changing different type of the scripting language or FDI, or man in the middle attack, they can disconnect one specific network. For example, maybe this specific one can be disconnected, or this one can be disconnected from the network. Or what happened in the Ukraine, that they actually stopped the power network for a specific area a long time. In Germany, it is also happened. Where is a control system? The control system actually controls the full grid or the partial grid or the substation. So if attacker can reach to the control system, they can the divert, they can mislead, they can disconnect the partial or full network by using this cyber physical system. So why we say this cyber physical system? Because these are the the entities that are connected to the internet, that are connected to the Ethernet communication. So we need to understand the cyber physical system. So these are the core understanding in between the grid and the cyber, which is we call this is the information network. Now, the security concern in the grid competition, which is we know that the main objective is to maintain. We need to maintain the confidentiality, data integrity, and the grid availability. As I said that in Ukraine, in Germany, in many other countries, they are actually suffering because of the attackers. They make some, the programming or attack. They actually enable the availability of partial network or full network. So this one already tested for the ICS industrial control systems, where they actually hampered the network to disconnect or separated the network from the main grid. So there will be a blackout. Okay, so there will be no operation. So this is the one problem. Another one is the integrity. Integrity is another issue that the someone inside and they can they can intercept the data, and nobody can feel that the data has been changed. And the confidentiality is another objectives to maintain the authentication, accountability, dependability, and privacy and safety. So these actually, based on these requirements, we targeted this confidentiality, integrity, and availability, which is a grid competition requirement for safety. Now we talk about the layer by layer, the grid attacks, where we need to understand about where the attacker can easily intercept or the attack. Okay, in the cyber layer, we can easily understand the database manipulation. For example, the customer billing information, the small grid or the private grid, the database or the meters, it can be manipulated, or the code manipulation, password hacking or cracking, malware injection, sleep deprivation, supply chain attack, and false data injection, channel jamming, message reply, and GPS spoofing. So by the GPS spoofing, someone can easily mistrack the wide area measurement system, so that the real-time communication to the grid will be interfered. So this is a big problem for the communication layer. For the physical layer, it is actually happened by the electromagnetic damages, or the false data injections, or the physical damages. I think someone is talking. Can you stop the mic? Hello? Hello?
Yes, sir.
Someone is talking. I feel disturbed.
Uh, Asha madam. Asha madam. Okay, I will tell the organizer. I will tell to remove those people. Okay.
Yeah, okay. So okay, I start again. The physical layer main problem is the physical damages. For example, the electromagnetic damages, and others can be like false data injections. In network layer, also the false data injections, the gray hole, packet sniffing, fuzzing, and rogue node and denial of service. So these are the basic, the attacking the names, or particularly for the the layer wise. So need to understand that the where you need to focus actually. For example, the physical layer, the electromagnetic damages is happen in the grid side, so that the generation will be hampered, or in the meter side, where the meter is electromagnetic, the device, it actually rotates. So if there is some electromagnetic the interference, the meter cannot read the exact the readings, or the exact the generation. So this is important for the physical layer attack. The security strategy measurements. So we need to understand the mutual authentication and key agreement. As I said, that the confidentiality is a problem. So how we can do that? If you see, this is a main aim to maintain that the integrity, confidentiality, privacy, and efficiency. So how we can do that? We can apply the elective cryptography. We can apply the biometric-based authentication. We can apply blockchain-based authentication. We can apply group-based authentication. Okay, to understand, to make some trustworthy, the mechanism to, have some mutual authentication to use the data center or utility center or the database from the grid device. Okay, so the IDS is another very important for the grid communications and the attacks. Okay, so the IDS can protect some of the attacks if you understand what are the techniques and how it actually can be done. So the host-based IDS, network-based IDS, cloud-based IDS, IoT-based IDS, and distributed IDS. So you need to understand which network need to actually consider which the IDS deployment. For example, if you are using the cloud-based data center, then you have to deploy the IDS cloud-based the deployment. If you have the IoT networks inside the grid or in the house or in the industry, or in the the multi-storage building, so then you can deploy the IoT based or distribution IDS. The mainly we use the signature based, federated learning, anomaly based, machine learning, deep learning based, or we can use the specification based or the hybrid based. So we can see that the network based and the host based, what's the basic difference? Host is the most one that can monitor a single device, where they can monitor the local activity, that incoming and outgoing network traffic, so that we can understand that who is trying to intercept the particular log or particular data or profile in the database or in the particular device. So the host base is giving the more benefits, okay, to understand the network traffic. But in network based, we can monitor also the incoming and outgoing network traffic at a single point of the network. So at the you can say that you have a house and you have the switch, and inside the by that switch can cover at least 5 to 6 devices. So you can actually deploy at the switch level or the gateway level, so that you can understand the network the based deployment for the IDS. So both are very the impactful deployment. However, I have seen that the host based is more the impactful to understand and to track the particular the cases. So these are some the more details about the cloud based and some of the principles. This more on the some distribution IDS. I will not talk about more this on anomaly based, machine learning based. So machine learning based actually uses the feature engineering, mostly using the feature engineering to extract the attributes for attack classification in smart grid. Mostly we have seen in our research that SCADA control center, they are mostly target place to hack the data, because SCADA is a system that can the is a heart of a smart grid that can maintain all the communication of the grid, grid 1, grid 2, grid 3. Doesn't matter how many and how big scale the SCADA can maintain by wide area network, local area network, or house area network. Okay, mostly the suffered attacks are data integrity attack, control signal attack.
Open elect 1.5 ಇರುತ್ತಲ್ವಾ
Variational mode
I
decompensation
will
attack.
one second, sir. I will tell all the audience, kindly mute yourself. Dr. Rupa, kindly mute yourself. Chanappa sir, you are there, so can you? Yeah, okay, thank you, sir. You continue.
Okay, thank you. So the SCADA is a heart of a smart grid network or the communication. So we need to really understand about the SCADA system to know the attacks. Okay, to know the attack, you need to understand the full architectural, technological, and what the software they use and how they actually control the full grid generation to the subscriber level. Okay, so we can maintain everything there. We can see that the the load profile, we can see the weather, the factors, we can see the in distribution network, in the power network, we can see the losses, we can see the electromagnetic interferences losses, we can see the heat interference losses, and weather factors. and we can also see the thermal effects, and by this all actually we can maintaining the information network, the information communication network. Okay, this SCADA system fully dependent on the information communication network. They have the PLC, they have the PMU, so that the software can maintain everything from the grid to the monitoring or the control center. So the distribution system, it can also hack or attack by scaling attack or smooth curve attack. Mainly they apply the bias classifier. Okay, and load forecasting, we know that load forecasting is very important to understand the next 30 days what will be your the uses. Okay, for example, in most of the countries we are using now prepaid based. Okay, so now for this month maybe I'm using different appliances. Some of the countries they have winter, some of the countries they have summer based, like Asia. So the winter they have more electricity consumption, so they need to know that next 30 days what will be my consumption. So based on that they buy the advance the electricity. So the load forecasting is very important, but there are some techniques that can be compromised by scaling attack, ramping, and smooth curve attack. Also, some other attacks like data integrity attacks also can be done here. So how you can maintain by using the machine learning ideas? So mostly we saw that the vector support vector machines, the Bayesian language algorithms, and K nearest algorithms, random forest, K means clustering, decision trees, and the principal component analysis, and the rule-based algorithms are very promising. We have investigated and seen that these are very promising algorithms, machine learning-based algorithms to investigate the attack prediction, and some sort of the load prediction, and to give some sort of the understanding on the the attack modeling for the SCADA and the control centers. And some of the the deep learning for the very object specific, we saw that the recurrent neural network and the CNN are very promising for the decremental techniques, and the generative techniques are very promising nowadays. We have seen that deep auto encoder and the generative adversarial network are very promising. We already investigated, and we also found that the substation automation transmission protective relays are mainly attacked by the MITM attack, false detection attack. Distribution system state estimation can be attacked by FDI, and automatic generation control can be attacked by the timing attack, which is mainly synchronization problem for the grid. For mainly, we are using the satellite-based timestamp. So the time delay attack is very, the bad kind of attack, so that the grid become non-reliable. The real-time operation is hampered. We have seen that by deploying the deep learning-based approaches. Some federated learning already investigated, and we propose some methods because it helps to learn the collaborative way without data sharing, and nodes can learn collaborative without data sharing with the central server, and centralized model with the decentralized training, and mainly to maintain the training occurs independently on local nodes. Post training models are sent back to the central server. So this is some of the benefits that can the rely on the federated learning, mainly when you have the multiple nodes. Of course, in the smart grid you have multiple nodes. For example, in one city one grid, is another city another grid, and then number 3 city another grid. So all the cities are contributing to the national grid. When the national grid is accumulating all this the electricity and distributed to the the distribution channel, so of course this federated learning is very promising on this large scale implementation, even for households, industry meters, advanced metering infrastructures, all actually will be benefiting by these federated learning based ideas. We also checked by making the hybrid based ideas. Then we saw that if we make the anomaly based ideas, signature based attack signature, and the traffic analyzer, so we saw that making this hybrid also, the making some level of hope to understand the attacks, and we can predict the attacks, in a certain level. And we see that the accuracy detection is higher by applying this hybrid mechanism. Some specification based are very promising. However, it relies on mutually dependent specification instead of machine learning techniques. It determine the rules for normal behavior, and any outside these rules are constant security threats. This is okay if you maintain this rule. However, this is the cost effective. Okay, and every time you have to maintain the specification based for the detection, it may not give you a particular freedom to the communicate with the random way. Moving target defense is another very nice and we can say the reliable technique for IDS. Main purpose to address the security concern against the adaptive attackers and aim to prevent the stealthy attacks on the smart grid. Main concept is to constantly shift among the multiple defense surface, include the changing network configurations and open ports, adds the uncertainty for attackers and complicating their efforts so that the attackers cannot the predict that what kind of the network you have, what configuration network you have, and so that they will be a little bit on bluff, so they cannot attack your particular device or particular node or your industry. Okay, so this is actually the advanced AI technique for some grid competitions. We see this is the component level which is the infrastructure. This one, we can see the distribution energy resources, we can see the transmission networks, and we can see the customer networks. So this is very important to understand how they are connected. Okay, so this is the application. We see that what level of the applications we can talk about. Okay, we can talk about like distribution energy management system, load management system, power flow optimization, general forecasting. So actually my focus is here, and here. We are working a current project. Okay, it is running project. Almost a large amount of funding is here for distributed energy. However, there are some other the problems like the data storage and security. Okay, this is the privacy, security, and the attack detection policies are here. Grid health monitoring analysis for load forecasting and balancing. Load fault detection we haven't focused here until now. This is out of our focus. However, the smart prosumer side like home energy management, energy forecasting, and information security, we are focusing now here. Why we are focusing here? Because this is a house. Okay, this is an industry that you are actually using your appliances. You have variable, the informations. You have automation software, and you have the different the sophisticated the softwares devices that you want to hide it from the other the side that people cannot see. Okay, but your meter can see that which application or which device are actually the taking the energy. Okay, so this is very important to the secure your device, secure your data at the home side or industry side, or your the corporate level side. So how you do that? You apply the artificial neural network for forecasting the day ahead load profile, machine learning algorithms for predicting the electricity price and the demands, deep learning for conditional restrict Boltzmann machine for forecasting the building energy consumption for a month, for a year. And we can see the dynamic differential evaluation for demand, the demand side management. So this article has been published, and we have seen that this kind of the methodologies are very promising, and we are still the investigating in our research, in our funding research. So you can see in a short that how the cyber attack and load forecasting for global energy the agenda. So from you can see the 2022 to until now I didn't focus 2024 in this slide. I will update later. But the main problem, everyone, everywhere was talking about the cybersecurity. If you see, is the industry 4 is something that connecting everything, okay, under one umbrella. And then the main problem happened, that is the cybersecurity. The Russia-Ukraine war, actually something we saw that the all-in control system, specifically power grid, was suffered or the attacked by both parties, and Ukrainian power grid was compromised. We saw in Germany, we saw in France, we saw in Kazakhstan also. There are some many the grids and some the control system were the compromise due to the cyber attack. So this is very, very important. The agenda for the energy business, which needs to secure the sustainable load forecasting and the data privacy. So we have seen that as we know that we have the several layers. Okay, for example, physical layer to application layer. Each of the layer are suffering the attacks. Okay, so it doesn't matter that you're working in physical layer, still you have the chance to get the jamming attack, spoofing, or the time synchronization attack. Or if you think about, I'm only maintaining the applications so that I don't need to think about the attacks. But of course, the flooding attacks, the social engineering attacks. Okay, the social engineering attack is very interesting. Okay, the users on the same office or same the application, they already have the access. They actually do it inside the home, inside the office. They actually attacking. Okay, this is social engineering attack and intrusion attacks. So this is something that we need to understand about the attacks in grid computations. So in picture, we can see that where the attacks has been actually done. Mainly the field devices where the sensor and actuators are connected to the the control transmission systems. When they control the transmission systems, they have the information actuations from the distribution, and then the field device sends the data and through the actuators and transmit to the information control center, which is the main control center. That is actually the level of the place that the attackers target. For example, the Stuxnet attack is the serious attack on the communication system directly involved to the phasor measurement systems and control centers. And we saw that the information platform and the fault identification methodologies data and real-time data and historical data are compromised. So this is very important to understand that how the attackers, where the attackers can steal. For example, the DODS system attack can compromise the grid distribution channel. So they can the control one a specific area to blackout or to separate the network. Okay, so this is very interesting. And also the command and control server can be easily attacked by using the MITM, Stuxnet, and data injection attacks. Okay, so we apply different methodologies, but we also seen that how the CNN and explainable AI for detecting the cyber attack in smart grid. We have investigated this one, and we saw that by our the methodology, we actually understand the attackers attacking capabilities, and we can predict with the higher accuracy applying the explainable AI with the shape and line. We saw the particular the model the occurrences and the activities that can easily definitive to understand the the predictions. So blockchain is another very interesting way to immune the cyber grid competitions by in several ways. Okay, it can give you the decentralization benefit in immutability and cryptographic advantages, and secure a smart contract in the smart grid in terms of the transaction of communication, where the billing section the generate the bill to the customer, or the the control center bill to the the generation side. So this is very important that if they use the blockchain, that is more secure from the endpoint to the the end user. So the the transactions are more secure in terms of the identity security. They can they cannot the attackers cannot hack the final data or transaction data. So this is a very the convince mechanism we have seen. We can apply for several way, but we have also have seen that the denial of attacks, but DOS is still able to hack this or attack this blockchain in smart grid. So this is some detail about the cybersecurity spec on the specifically the blockchain. We saw the denial of service attack, DOS, endpoint security and intentional misuse, and code vulnerabilities are there. And we also seen that the blockchain can protect a certain level of the trust, create the trust and give the confidentiality, integrity, and availability. But however, still the attackers can compromise the network by applying their the mechanisms, by applying their malware. So these are the simple the definition how the blockchain creates the blocks. Everybody we know already. So this is, we talk about that. I just told you that the DODS or denial of service can attack the blockchain. How it is happened? Because you can ask me that blockchain is very secure. How then it is attacked? If you see that the blockchain main point is to end device the transactions. So when the peer-to-peer communication is there, so what if one peer is somehow compromised, then the full network is compromised. So these DOS actually attack in any side of the peer. If you see the picture, okay, if you see in the picture, okay, if you see this is the DOS attack in traffic, where legitimate traffic in the server side or customer side, and then ultimately they can compromise the full the server unavailabilities. It doesn't matter how trust it is. So the attacker can try to gain the knowledge and try to get all the the valuable information from the peer side. And if one attacker already compromised and the sorry, the user already compromised and attacker the show that the attacker become a the proxy user, and then he is keep the making fool the other parties. So it is possible. So we have tested this one, and we found that even though in distributed nature, the blockchain can be compromised specifically by DOS attack. So this is the energy forecasting in smart grid. We saw that there are some the methods. We saw that the short-term load forecasting. We saw that the mid-term, and we saw the long-term forecasting. Okay, so for short time we can see that the few hours, or we can see the month or years, to understand the the demand and the pricing, to limit the the use, and to the save the misuses. This is the application that we already investigated and applied to our project. Okay, we have considered these scenarios to understand the load forecasting, and to specifically for the household. Okay, specifically to the household scenario, that we can actually in the consumer level we can see that how we can predict that at least 30 days of our the loads and demand loads. So the load forecasting in smart grid, basically we maintain to minimize the risk by predicting future consumption of commodities transmitted or delivered by the utility, and is a technique by the power or energy providing companies to predict the energy needed to meet the demand and supply equilibrium. To actually in the short form, we can say that it is an essential role in effective energy planning and distribution in a smart grid. However, due to the large data set of a smart grid, accurate data forecasting is still challenging when you have a larger the subscribers. So if you talk about the 1 million, subscriber or the 1 billion subscriber, then that is a problem. Even though you apply the machine learning, deep learning, it doesn't matter. It will take a lot of time. It will, the processing time will be very higher. We implemented only few, the nodes or few subscribers, smart meters, and we saw that the computational time is very high. So this is still open challenge, open research for everyone. If someone interested to work on the load forecasting in smart grid, can start here. So the machine learning, as I told you, that the machine learning is a hope for predicting the short term, medium term, and long term, the prediction. And we also see that the training and computational time and learning error, additional backpropagation process, and big data are major challenge for load forecasting. So if anyone interested can start work here. Okay, so neural network model for load forecasting, we said that we saw that RNN, LSTM, and GRU, okay, the gated recruited units is something that is more faster than the LSTM, but it may capture long-term dependencies as well as LSTM. So we also are investigating this one for better understanding of load forecasting. This is the LSTM mechanism. And we implemented our project methodology. We saw that, okay, daily basis, okay, what is the prediction? And we saw that the load forecasting result using the LSTM, we saw this is the actual one and the forecast load. So forecast load and actual is almost same in our implementation. And we saw that, by hours, by weekly. Okay, so we have seen that, okay, for example, here, this is the forecast and this is the actual. If you see that the testing is almost same, so we can predict the almost same requirement for the 30 days, or we tested only 30 days, and we're still working on this one, okay, but we limited the number of meters. If the meter are increased, of course, we need to investigate further, because the computational time will increase and the hardware dependencies will be higher. So the costing will be higher. So there are a lot of works need to be done here. A lot of researchers are working here, still open research. So I welcome my friends here. If anyone interested for load forecasting can start and can cooperate with me or collaborate with me. Okay, I'll help if need any sort of information. This is more results from our work. And this is we published already. Okay, this is our literature review published back in 2020. And after that, many papers also we published in the same area. If you can search on my Google Scholar, you can find it. So these are some, the federated learning for overcoming some challenges like reducing the computational time. So implemented the federated learning in machine learning technique that trains the algorithm across the multiple decentralized edge devices or servers holding the local data samples without exchanging them. So we can reduce some level of the delay, or we can improvise the computational time. These enable devices to collaboratively learn the shared prediction model while keeping them all training data on device, decoupling the ability to do machine learning from need to store the data in the cloud. So this is how we can actually mitigate some level of the competitions. However, if a large scale of the practical implementation, specifically when you go for the Python coding, then of course it needs a high level of server to understand the full computations and to complete the full the algorithm. It needs time. Okay, so for the sustainability, grid sustainability, we need to understand so many things. Like we know that the grid competition is actually unidirectional, centralized, and hierarchical. We know this one already. But we need to understand that what transformation can drive this to the upgraded in the collaborative smart grid, okay, way. So we need to understand like ICT, that information communication technology, which is two-way communication. We need to understand how we need to sense the data, how we need to understand we need to sense the data from smart metering. We need to understand from the grid metering and in Internet of Things, how you can compose in the system, in the grid systems, grid competitions. for real-time actions and asset management, we need to transform ourselves for the smart competitions and energy generation diversity. For example, renewable sources, small generators, okay, distributed energy resources, energy conversion techniques. Also, we need to know that how we can improve our quality, more improvise the reliability, sustainability. We have to know that this is not our my focus, the green energy. Maybe you can work here, okay, for the safety and the increasing the green energy, for example, solar, hydro, etc., etc. You can focus here. And then you can, when you go for more green, then you can regulate the carbon dioxide emission. Maybe you can protect the consumers. Okay, so you can, improvise your taxes. And so many things are here for the sustainability. You have to consider it. And the collaborative smart grid can be the bidirectional network, distributed, automated, resilient, self-healing, and participatory. So in this green zone, we can see that this is a complete sustainable grid competition for smart grid. So this is what my topic covered, the grid competitions, including we covered the advanced techniques. We covered the attacks, advanced the threats, and we tried to show some mechanisms and some of the normalization and the standards that has been maintained through the techniques. We tried to show a partial way. You can explore from here. If you have any questions, you can ask me. Thank you.
Hello.
Yeah.
Any question from the participant side? Thank you, sir, for giving very elaborate. You have included everything, blockchain, and then AI, and everything you have included in your presentation. So
Yes, I tried to include the high level competition, as your topic is quantum competition. I did not include quantum, but I include the advanced competition in grid computing.
very, very depth. So computer science related people who are here, they will definitely get so much help from them. So and what we are doing, sir, we are recording the session and we are making the YouTube.
Oh, wow, that's great.
YouTube, yes. After that, I will share you also your YouTube link.
Okay, okay. I can
Yes,
say
yes.
it is not only the computer science research. Many of my PhD students, they're from electrical. So smart grid can only computer science people don't will not understand, because you know why? The electrical devices, the characteristics and the architectures, it is difficult to understand by CS graduates or the CS people. So if the candidate or the researcher have the background on electrical and the computer science, or we can say that electrical and communication, they can easily make a bridge and understand. Of course, the computer science people need to be involved here to understand the algorithms, to understand
Blockchain
the,
part,
yes, the security and
yeah.
the artificial neural networks.
Cyber attack. Yes, yes.
Yes. So your team, the 2 or 3 departments or the faculty can make a strong collaboration to write this kind of projects and can get the funding. And this is very top priority project by the United Nations. We are under SDG 9. It is very important, and high priority area for research and development.
Because it will deal with the cyber attack.
And also we are dealing the real-time network.
Both.
Yeah.
So
I
from
have
the
a question.
audience, yes, yes.
I have a
Yes,
question, sir.
yes, madam. Yes, madam, you can ask.
Yeah, good
Yes.
evening, sir. The section was very informative. I have one
Yeah,
question.
thank you.
How to take over the security concept in the smart grid? Where
Yeah.
exactly we need to apply the security concepts? Like cryptography, as we told that privacy preservation.
Okay, this is a good questions. I can show you one diagram so that you can understand here. This one, okay. So if you see this is your, the electric grid, okay, where you go outside, you can see that the wires, right? Pole wires, you can see the transformer, you can see the distribution transformer. So, and you have your house, your office, your, the petrol pump, electric car. So these are actually the scenario of your network infrastructure. And backside, all these have the server side, server where they track and record the data. Okay, who using how much, the electricity. So all the billing information is here, including the like, for example, one party who generate the wind based, the electricity and distribute to the network, and one party maybe from, Uttar Pradesh. Okay, they have a power plant based on the solar. Huge power plant, they also contribute to the national grid. Okay, and someone maybe from maybe Bangalore from nuclear based, they also contribute here to the grid. So how it happens, they have meters. For each of them, they have meters and meters and meters. So these all connected to the control center. So where is the control center? Here. So when they connect, they have a communication network. That is the information communication technology network. We have the switch, we have can be the wireless, can be wired, can be fiber optic, can be any another communication channel. So the attackers, they are very interested to, the attack this kind of the meters. So if they can control this one, they can compromise this solar system network. They can compromise this wind system. They can compromise nuclear system, even though when you have this, for example, you have this industry, you also have the meter here, or you have the control system here, ICS, industrial control system, ICS. Okay, so one ICS, maybe 1,000 ICS inside one industry. So these all are connected under one ICS. So this is actually under the SCADA system, sorry, SCADA, SCADA system. If you study, if you can find the SCADA system, which is actually under this SCADA is under one software. We call this wide area measurement system. This is the WAMS. Okay, so this WAM also have the small devices we call the PMU, or earliest time we had the PLC. You are actually, maybe some of you already know the PLC. So the PLC is not using anymore for the smart grid. They replaced by the PMU. So this is the advanced, the device who can track all the electric pulses, the voltage, amperes, all the record by these PMU devices. Any types of error, any types of miscommunication, fault are recorded by this device. And these devices are directly connected to this one more device, which is we call that PDC. Okay, PDC. So these PDCs are connected to the control server. So when the attacker try to attack here, this is also ICS, okay, and try to attack here. Ultimately, they can control all this network. They can control this network, they can control this generation, even though for one industry, maybe one, the power, the car, or any petrol pump, or your university network, they can black out your electricity for 2 hours, 3 hours. For example, you have a very important meeting tomorrow. Just you started meeting, there is a blackout. Who did it? Is it the normal disaster, or any problem, or some attacker make it? Anything can be possible, because if your network have these high level devices, the attacker also have these kind of attacks, like they have DOS, DDoS, FDI, MITM, Stuxnet. It's very, very, the dangerous, these attacks, very strong attacks that you cannot even predict when you everything lost. So this is the scenario. Do you understand? If you have more question, you can ask me.
What are the solutions? Is it one is on this cryptographic concept where we should use to protect the data, or any other alternate solutions are there to
Okay,
protect the
excellent. This
private
question,
data?
excellent question. I can show you here. Okay, so if you see that you have the requirement of this, so you have to make the authentication, you have to make the authentic accountability, you have to make the privacy, you have to make the safety, dependability. So where, why? Because you have to make this CIA, which is the confidentiality, integrity, and availability. So now you find your algorithm where is suitable. So if you work with the authentication, so you work with the authentication algorithms, you work with the cryptographic, you work with the cryptographic algorithms. If you want the integrity and if you have the availability, so you know where to implement. So now in the meter side, you can use authentication, you can use the integrity, you can use the availability for the greater network. Okay, so availability means that here is one node, is a one node, so they have a connectivity. If someone break it, there is no availability. So this is the availability attack. So you know how to make this. Okay, so this is actually they have different mechanisms. So they bypass. Okay, they have the network. So you need to know how to bypass and when to bypass and how to protect this. So this is how you need to understand about the grid infrastructure first, and then you have to understand which layer you are need to work. Okay, for example, if you are CS researcher, then you have a very strong area to work on the protocol, routing protocol, or you have to understand about the switch to switch communications or Ethernet communications. So you need to know that how you can protect the packet sniffing when you transfer the packet. And you need to know where the gray hole attacks, where you need to the false FDI attacks, and also the fuzzying and denial of service. So this is actually your area. Or if you are working with the application layer, for example, communication layer. So you need to know about detail about the channel mechanism, how people can jam your channel. Okay, how people can intercept your messages or replay your messages, or they can spoof your GPS signal. So this is need to understand how to protect the the malware injections or the code manipulations. This is what you're understanding. So if you need to know that the security strategy and measurement, you also need to understand the full grid infrastructure. Actually, where is your focus? You want to focus on a smart meter, you want to focus on SCADA system, or you want to focus on wide area measurement systems. So when you talk about the authentication, you can design your maybe lightweight authentication. There you see there are many techniques here, like group based, blockchain based, biometric based, elective based. So now you can work, like you can choose your area and design your algorithm, and then application wise you can propose. Okay, that's all.
So we can work on
Yes.
optical fiber system also.
Yeah, as I told you that if you see this network, it's a very interesting one. If you see that not here. Okay, if you see that this is the fiber optic. You notice this one, fiber optic, WiMAX, cellular, satellite, or PLC or DSL. You can even use the DSL, the digital subscriber line, telephony system previously, the copper cable. So the fiber, this DSL is obsolete now because the fiber optic introduced. They are the obsolete. The PLC is obsolete by the PMU. That I just told you, the PMU. And satellite is still there. WiMAX is no longer there because we already go through.
Wirelessly.
Yes, wide area measurement system. They have the SCADA system, so they avoid this kind of, because of the attacker easily can intercept the data. They can analyze the packets by wireless. So we no longer use this one. So
So
only
it
this
means
fiber optic, satellite, and PLC. Yes.
it means
Where
that
okay,
this
where
kind
you
of
use the
project
fiber
can be
optic?
done by many people, by
Yes,
combination of many department interdisciplinary project.
yes, can. Like if you see that where you can fiber optic implemented. For example, you have a you have a the network utility where maybe it is in Delhi. Okay, in Delhi, maybe this is Delhi. Maybe your one of the network has in Calcutta. Okay, but your full data concentrator or data channel is in different area. Okay, so you have to connect this one to the fiber optic for long distance communication, right? Or you have to come through the satellite. Satellite is very expensive, so obviously satellite is going to is not a good choice. So you have to come up with the fiber optic communications.
Optical fiber.
Yes. So there are a lot of the connectivity there. You can connect the optical researcher. You connect can be CS, electrical communication. This is a breeze. Is a real the research domain. So people from different the domain can the collaborate together. It's a strong. In my projects, if you see, I told you here is this is the all running. So this project, one from the communication, one from electrical, one from directly from the smart grid specialist, and I'm in the the smart grid specialist. So we have four to five members, each of them. So this is something that you have a real time collaboration scope. But I must tell you that you need to understand this network. You need to understand the detail of the network to define. But the challenges are here. I can show you the challenges. Okay, I just shown you the challenges. So maybe you can come up with a team and find some interesting topic. You can involve me so that I can help you over the time to generate some ideas, and then yeah, we can proceed like this. I like the questions. Anyone?
So I think all the question he answered. Anyone else from the participant? Participant side? No. Okay.
If I come to your next presentation, any of your next presentation, I will come with quantum security mechanism, which I am actually working on it. One of my project will be matured soon. Then I will come up with that presentation. That is another interesting topic to be present.
So quantum, sir, you are working on simulation basis only, no hardware.
No, hardware based.
Hardware based.
Yes. No,
Oh.
for the time being, we are using a small, the Raspberry only.
Mm. Okay, hardware based, we have not come across till now.
No, we are working. We are working with the Raspberry 5,
Okay.
and we have some equipments from the. We also working on the smart grid synopsis. That is a small scale implementation. We can say that test bed. Of course, any of my work we consider test bed first.
Okay.
Computer-based simulation is not so reliable solution.
Hmm. Very good. Very nice, sir. So, sir,
Yeah,
thank you
thank
so
you.
much. I think no question.
One more question.
Yeah.
Ma'am, I request now the speaker of the thing so that if you are able to or arrange one of the section of like some demo on the practical concept or the research area, how they taking over their research part of any one of the problem what the sir has been explained.
Yeah, that can be done. Yeah, understood your question. So maybe one or two, my research full, I mean contributions and like this. This
Where
one,
hardware is
for
there.
example.
Correct, Aruna?
Yeah, yeah,
Aruna,
yeah,
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 madam?
yeah.
yeah. Sure. Yeah,
Yeah.
yeah, ma'am. Yeah, ma'am.
Yes. So where hardware is involved, that type of things she is more interested to see actually.
Yeah.
Yeah. So for that case, of course, you need to make a the arrangement. Maybe not this so soon because I'll be busy with the exam is coming. Maybe in 3 or 4 months time, then we can arrange one special talk or a special lecture so that we can go for it, especially maybe one of the implementation full project concept with the real-time implementation, so that you can understand about the synopsis, problems, solutions, and the implementations.
Yes, yes.
Yeah, it can be done. Actually, I did not include so many, technicals, because I thought that it will be boring, because too many mathematics things sometimes is very sleepy in the, short time talking, so short time, the talk delivery. So I make it shortcut.
Yes.
So anyone else? It is very interesting one. If anyone want to ask, or later you want to ask, you are open to ask me. You have my details already, so that you can search me online. You can find me. Okay, so I'm really, welcoming everyone, and I know many of your, colleagues already have collaboration with me, and we are working. But it is not a good collaboration because only one-sided. I want both-sided. Real-time projects, like we apply for funding, real-time funding, maybe in your country, or in European zone, or in other zones, so that we have a real-time participation. We can get some fund, and we can share the fund.
Sir, just I want to know that here, like my specialization is biomedical healthcare devices. Yours is very high level of work you are doing, where one township is infrastructure you are changing. One township. That's why
Yeah,
yours
smart
is
city.
in bigger end
Smart city,
because
yes.
electric. Yes. So it is for the infrastructure. Mine is for human healthcare. Some device, small device we are making. All the devices are useful for
I have
handicapped.
one project. I have one project. We already developed the proposal. I was thinking that we can improve that proposal. Maybe I can involve you to improvise that project. That is also artificial intelligence based. Mostly we are using the deep learning based for Faculty of Medicine, to identify some specific problems, specifically electronic prescription, okay, prescription, and the data and security stuff. Maybe you will understand that one, so I can involve you in that project. Next time we can have a special session, both of us, and then we can discuss about it.
Okay, okay, very nice. Thank you very much for elaborated way. And not only the you have given the talk, but you are happy to collaborate with all of us, whoever are interested. So I'm really very much thankful. So this type of FDP we are doing not only just for the namesake FDP, we are doing the very good networking. We are understanding the technology. uh, Maybe I am not from electrical background, but by seeing that I have well understood that what kind of work you have done. So this type of research work and all separately we will not able to study. So when doing during the FDP time, if we can listen, at least we'll get some idea. And really, I'm very thankful, Kamrul sir, for coming and giving the talk on the such a advanced topic where you have involved everything, smart grid and everything you have involved. So once again, thank you very much.
You're welcome. And if you have any question, any participant have any question, can email me, and please give them my email ID so that they can
I'll
communicate
give,
with
I'll
me,
give.
and they can also find me in Facebook so that they can directly communicate with me. Thank you.
Thank you. Thank you very much. Thank
Mm,
you once again.
okay, welcome.
Okay, participant, now the link of the feedback link will be pasted. Okay, till then you be here. After that you can leave. Dear participant, I think feedback link is posted in the group chat. Okay, all of you kindly fill the feedback link. Thank you.